Hi, we are Group 5 and I am Solon Chi.
I'm Lauren Cho.
I'm Chen Ai. I'm Lee Guanpa.
And the filmer is Chairman Ki. We are here to present our projects about the properties of the electromagnetic and optics of bulk glass and timber, as well as the performance when facing insets and worms. And this is our outline.
As for the background, it is crucial to study the properties and behavior of the material. By obtaining knowledge of physical properties and behavior of the materials, we can simply observe the data analyzed to measure and use the materials effectively. In addition, we can minimize or even avoid using the material in a wrong way. For the objectives, Solon has mentioned this, so I'll just skip it. For timber, the simplest form of definition is wood, preserved and prepared to be used. Timber has been highly demanded raw component, especially among manufacturing industry, including construction. Its constant recognition for its excellent versatilities maintains moderate price and abundant quantity attract audience of all customers. Properties includes density, softwoods, hardwoods, moisture content, directional properties, stress and strain relationship, thermal properties, and fire resistance and durabilities. Timber framing is also referred as a post and beam, which is method of timber construction partially dependent on the timber frame as a primary structural support for the building. The construction technique of establishing timber framework linked together with wooden plank mortise and joints are over centuries old. Historically, each region performed slightly different styles and types of framing. Each frame was categorized and the name was given by carefully examining the types of foundation, walls, intersection, procedure of the beams, utilized and bent timbers, and the details of roof and framing. These are the four, I'll be introducing the four basic types of timber frames. First, on the left is the box frame. It is simple. Timber frame consists of slightly slanted vertical and horizontal pieces with a common rafter roofs with no purlins supporting in the middle. The load is carried by the external walls, which acts like a lid on a box. On the right, it's a post and truss, currently used up until now. The form consists of purlin roof, and both walls and roofs are firmly united within each cross frame. Key factor is the principal rafters are linked into the tie beam, and this permits roof trusses to hold purlin, which in turn carry the rafter and the cover for the roof. And the left is outlet frame. The complex form supplies additional internal room by separating the structure into central nave and two-sided aisles. Wall posts turn internal arcade posts, and the aisles are roofed over with lean-to roofs at an angle identical with the main roof. And finally, on the right, that's the crock frame. Due to its simple architecture and sculptural value, crock construction is extremely popular and most flammable. The form is considered to be a cross frame, which consists of pairs of inclined timber which meet at the apex and are planked together with some sorts of leash. Uses of timber. The timber has multi-uses, but predominantly function as a material for construction, furniture, and paper production. As it is in a rough state, it can be effectively used to create furniture since it requires further crafting. Majority of the trained craft works are firm and sophisticated due to high durability of wood itself and the exhibit of richness and nature it emits. On the other hand, finished states of timbers are transferred to necessary construction site to be used as a framework, roof, walls, and floors. There are a wide range of various applications to use timber, for housing to commercial building. Although majority of the ordinary buildings are composed of prefabricated steels or concrete, timbers can be found in interior work such as stairs and platform as well. And for their glass, it is the definition of the glass. It is a substance that is extremely brittle, either transparent, translucent, or opaque. To create a glass, you're required to fuse sand and soda and lime and cool really rapidly. Properties of glasses are chemical composition, viscosity, glass transition temperature, coefficient of thermal expansion, density, and last, heat capacity. And these are the types of glass: and annealed glass, toughened glass, laminated glass, cuffed glass, mirrored glass, patterned glass, extra clear glass. I'll only be interesting just 3 out of this since we're running out of time. Annealed glass is a basic flat glass product that is first a result of flow process. It is common glass that tends to break into large jagged shards. It is used in some end products and often in double glazed window. Second, toughening glass is treated to be far more resistant to breakable than simple annealed glass, and to be break in a more predictable way when it does break. Thus, providing a major safety advantage is in almost all of the applications. And last, laminated glass is made of 2 or more layers with glass with 1 or more interlayers of polymetric material bonded together in their glass layers. Laminated glass offer many advantages. Safety and security are the best known for this. So rather than shattering and impact, laminated glass is held together by interlayer. This reduces the safety hazard associated with shattered glass fragments, as well as to have some degree the security risk associated with easy penetration. And last, for usage of glass today, flat glass comes in many highly specialized forms intended for different products and applications. Flat glass production by way of the plat process is often further processed to give uncertain qualities or specificities. In this way, the industry can meet the various requirements and needs for the construction. And now for the optics.
Thank you, Richard. Okay, I'm Chen Lai-Sen, and I'm going to talk about optics. Optics, actually, what is optics? Optics is about the property and the behavior of light, which include refraction, and dispersion of light. The primary source of the light is in Earth is come from the sun. We can observe things and material from the sun under the sunlight. Once we see an object in our eyes, it is usually the light ray of the object translate and enter the eyes to form an image. A near object, you can see that a near object will form a diverged light ray, and the distant object will form a parallel light ray, and finally they come to the retina and form the image. In the next part, I will talk about the property of the light, which is include speed, refraction, total internal reflection, and interference. For the light speed, light ray has the fastest speed in the universe, which is 300 million meters per second, if no object is blocked. It is too fast, so when an object moves, people can observe it immediately. However, if light enter an object, it it will slow down. The amount of deceleration depends on the density and the material of the object. If the material is non-transparency, light cannot pass through it. And if the density of the object is too high, the speed of light will reduce. For example, light speed will reduce by 30% if it travels in water compared with its travel in vacuum. And the slowdown of the speed is called the refraction. In daily life, some material, for example, water and glass, are transparency. In other words, light ray can pass through them. When light rays are passed from one medium to another, which will have different density, the speed and the direction will change. The light ray will bend at the boundary between two medias. When people look into a river or water, you can see from the figure that the object was bended under the water. For the total internal reflection, when a light ray enters an optical less denser media, it will bend away from the normal. Well, you can see in the case 1, when a light ray is incident on the straight edge of the glass's block from inside, the reflection will occur, which is shown in the first figure. And you can see from the second figure, as the angle of the incident keeps increasing, the refraction rate will become dimmer. And at the critical angle C, the refraction rate will travel along the straight edge of the block. This angle is the critical angle of the glass. And in case 3, when the angle of incident is greater than the critical angle, we cannot observe the refracted ray anymore. The whole light ray is reflected back. Actually, why is it so important to talk about the total internal reflection? It's some material which is transparency because the reflection always occurs. It has a very tiny opportunity to have total internal reflection. However, when study other material which is not transparency, the reason for that is total internal reflection is always happen. So we can not see the reflection rate behind the object. For reflection, light can reflect off the space. The reflection allows us to see the image in the mirror. Well, when the parallel line strike a smooth surface, you can see from the first figure, the reflection is also the parallel. This kind of reflection is called the regular reflection. It will form a parallel reflection which can be observed. However, if it passes on a rough surface, it cannot form a parallel reflection. It is called the diffuse reflection, and no image can be formed in this case. Last, it is about the interference. It is a phenomenon that occurs when two beams of light meet. Two light beams will either merge and enhance one another to interference to make the merged beam less bright. Depends on the nature of two beams. They are called as constructive interference and destructive interference. After that, let me talk about the timbre with the nature of optics. Well, by 4 aspects, it is reflection, refraction, total internal reflection, and interference. Well, timbre is not a transparency material. As the previous part of the PowerPoint, if the material is not transparency, it means that total internal reflection is always happen. Light cannot pass through it. Also, the timbre will have a reflection, so you can see the color of the timbre. As well as the reflection, you cannot see any reflection because the timbre is transparency. All the lights pass through it will be totally reflected. And another reason to cause that timbre is interference is about the to cause timbre that is transparency is interference. That timbre will have that timber will have a light ray to disturb the light source, for example, sunlight. As the interference is destructive in nature, it makes the light dimmer or even cannot be seen.
Thank you, Michael. And I'm Solon Chi, and I'm here to show you the literature review. Well, the book we have read is named The Handbook of Glass in Construction. Well, the book tells us that the structure of the glass. Well, different composition of glass will have a different properties. But basically, glass is the basic liquid structure. Therefore, most of the glass is transparent. And why glass can reflect light? It is because glass absorbs and re-emitted energy. Energy of photon from light are trapped, absorbed, re-radiated by free electron in the glass. Therefore, reflection occurs. Common glass is transparent and can reflect visible light. However, some glasses cannot reflect IR and UV light because they have too high or too low energy. Why some glass is not transparent is because of impurity. The most common impurity found is iron oxide. And light can pass through glass easily because glass has a smaller molecular size than light. Well, you can see in the table, the wavelength of visible light is around 4,000 to 7,000 angstrom units, while the individual glass molecule is just 2 to 3 angstrom. Light also, when light passes through glasses, it also undergoes refraction. The refractive index of glass is 1.5 to 1.9. What is refractive index? Refractive index is the ratio of speeds of light travel in vacuum to the speed of light travel in the medium. But the books tell us that different shape will have different performance. Okay. For parallel side glasses, when incident ray is parallel to the reflected ray, it is because the deviation has been cancelled each other at a point A and point B. For not parallel side glasses, reflected ray is straight away from original path. It is because the net deviation. When light enters prism, it also undergoes dispersion. The mean dispersion is the differences of refractive index between red light and blue light. Different glasses also have different performance. We can look at the mean dispersion. Light borosilicate chrome glass has a mean dispersion about 0.0079, and double extra dense flint glass has 0.0441. Although mean dispersion increased with refractive index, there is no evidence to show the relationship between these two facts. If we want to look at the electromagnetic property, we need to first look into electrical properties. Glass is a good electrical insulator. It is because it has high electrical resistance. However, for liquid glass, they are good at electrical conducting because they contain mobile metallic ions which can produce current. And now I'm going to show you the optical property of glass. The first one is transparent. Well, we can look at our daily example, our glass. Well, glass is a lens here you can see. And lens is made from glass, crystal, and resin, which is transparent. Therefore, after we're wearing the glasses, we can see things. From this diagram, you can also see that light can pass through a concave lens. Therefore, glass is transparent. The second behavior is refraction and total internal reflection. We can see from when light passes through glass block. And I found an experimental video from YouTube is talking about Snell's law of reflection. I've used the data from the experiments, and I found that When the incident angle becomes greater and greater to 85 degrees, the refractive angle cannot be observed. The refracted ray is disappeared. However, in the same time, I can see the total internal reflection is clearly observable. Therefore, refraction and total internal reflection is occurred. And moreover, dispersion can be observed too. Well, you can look at this photo. The diamond sparkles and when light shine on it. However, this picture is neither a diamond nor crystal. It is crystal glass. Therefore, some glass also undergo dispersion when light shine on it. And I found another experimental video talking about white light through prism from YouTube, and it talks about light really. When light passes through prism, it really has the nature of dispersion. And I would like to compare the optical property between glasses. Well, different glasses has different behavior when comparing the refraction. I would like to use a borosilicate glass to explain this. From the table, you can see that different refractive index will have different refraction behavior. You can see that the highest refractive index, which is the silver borosilicate glass, is light bends the least away from the normal. Meanwhile, the low electrical loss borosilicate glass has a lowest refractive index. The light bends away the most from the normal. Yes, borosilicate glass, we can compare it by the perspective of refraction. However, it is much more significant to look at its chemical resistance. Therefore, borosilicate glass is commonly used in laboratory glassware. It is because it has great performance in chemical resistance. Another comparison is transparency and energy absorption by comparing another daily example, sunglasses and glass. Well, you can see from the photo, sunglasses is much more darker than normal glass. It is because a darker lens is used to absorb energy, which is UV, and therefore, meanwhile, a normal lens did not absorb any energy. And you can see that the transparency of a normal lens is excellent, but the darker lens, it depends but it is still transparent. It is because darker lens has a extra compound, which is some chemical compounds.
After compare the glasses, I will have the comparison about the timbers. Well, here is a comparison about the thin timber and the normal timbers. You can observe from the figure, due to the modern construction technology, a very thin wood can also have transparency. You can see the light can pass through the wood. It is because between the atom of the thin wood, it already has some space which will allow the light to pass through it. But it is not about the wood property. For the normal wood, you can see from the furniture and the wall that is made by the normal wood, which we discussed in the previous part. It is not transparency at all. And then I will compare the optic between the timber and the glass. Well, you can see from the table that a thin layer of timber will have this reflection. It is similar with the glasses, but however, the thin timber will have the glasses will have a better reflection and a clear image. For the refraction, the thin timber is also have the same result with the glasses, but the thin timber will have the dimmer light to provide it. And for interference, as timber is a transparency material, although if it's seen, it still produces destructive interference. It causes that the refraction of the timber is dimmer. Last, for the transparency, the glasses has a better transparency than the thin timber.